Hypothesis testing from Chapter 8. The first type of hypothesis test I'm going to be looking at is the 1 prop z test. This is where you identify that it's a proportion that you're looking for. Now, when you see the data, it should be clear whether the question that was asked was a yes-no type question, in which case it's a proportion, or a how much, how many question, in which case it's a mean. The first two problems I'm going to deal with proportions. This is going to be the report that you're going to fill out. I've filled out pretty much everything I can, including some of what you are going to be given, putting it in the obvious spots, and I've left, well, quite a few blanks, and that's going to be additional work that you have to put in. In this case, suppose that a claim is made that a certain percentage of individuals have a property. In this case, 68% have the property. Somewhere you are going to be asked to test the claim, and you are going to be given some keyword. The keyword is going to be important because that's going to specify which of 3 possible inequalities are going to go here. It might be that you're told that you believe that the proportion is greater than 0.68, so put a greater sign here, or less than 0.68. Or conversely, you might say that you think that this number is too high, in which case the alternative hypothesis, H1, is that P is less than 0.68, or that you're told that this value is too low, in which case the alternative is that the true proportion is greater than 0.68. There's going to be some keyword. One possibility is that you're just checking to see whether the claim is either correct or incorrect. If all you're asked to do is test to see whether the claim is true, is correct, then no direction is specified. So the null hypothesis always has an equal sign, will be that the proportion is 0.68. The alternative will be, well, that the proportion is not 0.68. I like putting the claim at the very beginning of my sentences. For some reason, in my math lab, and it mirrors what the author does, the claim is at the end, after they tell you the data. I prefer that you not look at the data until you make this decision, because sometimes the data misleads you. After you've made this decision, you also have to specify an alpha level. If I don't mention an alpha level, then use the default value, which is 0.05. Typically I'll mention a default value, or typically I'll mention an alpha value. This is how scared you are of being wrong, how scared you are of, well, making a bold claim and it turning out not to be true. In some instances, 0.05 makes sense. That's often used in the social sciences. In medicine, it often goes down to 0.01, 0.005, or even 0.001. Sometimes you see alphas that are very close to 0. Let's use the default value for the behavioral sciences. Let's use 0.05. At this point, I'm ready to look at the data and to run the test, and that will all be done on the calculator. So, stat, test, 1 prop z test. I see it on line 5. So, enter. P0 is the proportion from the null hypothesis. So whatever this value is, put it in here. So 68%, 0.68. 900 is the number of individuals that said yes, or the number of individuals that had a certain trait. N is the total number of individuals that were looked at. So you can see that this value, and this value all go into the calculator. The fourth line is going to be this. So it's these four that go into the calculator. You have to say which of the three inequalities you're using. We're using not equal to, so I'll leave that selected, and I will calculate. What's on this screen is meaningful. First, proportion not equal to 0.68. That's what I have written here, my alternative hypothesis. Z, remember that this is a z-test. It's a z-test with a single proportion. For my test statistics, and z is a test statistic, I want 3 decimal places. It's a common standard. So z would be 5.198. Next, you've got 2 different types of p. There are actually 3. First is p0, which was 0.68. Second is p hat, which is the proportion in the sample. 900 over 1200 is going to be 0.75. For proportions, I like knowing x, n, and p hat. The other is going to be this p. This is the probability of such a sample arising by chance when 0.68 was correct. Now, I know it starts by looking like it's 2 point something, but pay attention to the e to the minus 7. So it's exponential notation. I want 2 significant figures. So I would write 2.0 times 10 to the negative 7. Now that's something that could happen, but would be a huge stretch. How often? About 2 times in every 10 million trials. A 2 out of 10 million chance is extremely unlikely. The better explanation is that 0.68 is wrong and that the proportion is not equal to 0.68. Here, you're comparing p to alpha. So I'm just going to move this value over to here, and now you specify whether this number, that would be 0.0000002, is greater than or less than 0.05. In this case, it's less than. Now, this is going to be the basis for our judgment. I call this justification. I call this judgment. I've got two possible judgments. I can either reject the null hypothesis, or I can fail to reject the null hypothesis. I use the acronym FTR. You reject if it is less than, if p is less than. You fail to reject if it is greater than. You don't really have to worry about it being equal to, but for the record, you fail to reject if it's greater than or equal to. In this case, since I had a less than sign here, I'm going to reject the null hypothesis. So this is going to be the report that I want you to do. You can see that what you're doing is filling in all of the underlined. This is the only thing that would not be included. I do like one prop z test to be at the top so that you show me what you're doing. Next problem. It's going to be highly similar. We're going to have another proportion. This time the claim was that 8% had a certain property. Suppose that somewhere you see the claim that the actual proportion is lower. That's going to be your key term. Somewhere the word lower is indicated. That means that you believe that the true proportion is less than 0.08. If I don't give an alpha, then you're going to use 0.05 as the alpha. 0.05 is the default. I typically give it, but if I ever do not give it, use the default value. Once you recognize that this is lower, we should be all set to plug it into the calculator. So, stat, test, line 5, 1 prob z test. P0 is now going to be 0.08. That's 8%. X was 77. N was 1264. Now I do have to change the inequality because I want a less than. This is going to be my inequality. So I toggle over 1, hit enter to make sure it's selected, and now I can calculate. I'm checking to see whether the proportion is less than 0.08. My z-score was negative 2.501. Now that's more reasonable. Remember that 95% of things happen within 2 z-scores. 5 z-scores is very rare. 2.5 z-scores away, in this case the negative just means 2.5 below the mean. But 2.5 z-scores is something that happens, but it's not that likely. You'll see that the probability that they give is 0.0062. Now 0.0062 is less than 0.05. So once again, I am going to reject the null hypothesis. The one thing left to do, p hat, let's give it 3 decimal places. 0.75 was because this turned out to be exactly 0.75. 0.750 is probably the way that I would write it. Here, I've got 0.0609, so I guess I should write that as 0.061. So the claim was that 8% had the property. My sample showed that only 6.1% had the property. Now that was lower. Was it so low that it was better to give up on this claim? That all depends on whether p is less than alpha. You don't like to give up on claims unless the claim is just very unlikely. What counts as very unlikely is whatever you set alpha to equal.